Part B. Lactate something is an enzyme found in nearly all living cells. Measuring the levels can be helpful in monitoring the effectiveness of certain medical treatments. For a particular group of patients, the distribution was normal, so it's a normal distribution, we know, so we're told that, and it had a mean of 210 and a standard deviation of 15. Now there's no sample in here, so this is just telling us about the distribution of LDH levels, and it has a mean of 210 and a standard deviation of 15. Okay, find the proportion of patients in the study with LDH levels between 200 and 240. No sample in here. This is just the data. So we want to go between 200 and 240. Okay, so we want the proportion in here, or the percentage in here. How do we do that? We need to get the z-score. We need to put this onto the normal distribution, the standardized normal, where that's 0, and the numbers along here represent how many standard deviations you are away from the mean. So 240 is how many standard deviations away from the mean? 240 take away 210, which is 30, and 30 divided by 15, which will give you 2. So we know that the 240 is 2 standard deviations away from the mean. That's the z-score. 200 is how many? Technically that should be a lot smaller, but anyway. 200 is how many standard deviations away from the mean? Well, let's look. 200 take away 210 divided by 15, which is minus 10 over 15, which is minus 2 over 3. Okay, so that's minus 0.666. And again, I've always warned you, the 0.6 with a dot on it, be careful. That's 0.67. Okay, so 0.67. Now what we want is we want this area in here. So remember the area, the total area under the curve is 1. So we want the area between here and here. So we want to find the probability that z is less than 2. In other words, that's all of this area. And then we want to take away, not great drawing, but we want to take away that piece. Okay, so how do we find this piece? That's just the straightforward, the probability of z is less than or equal to 2, which if you look up the tables is 0.9772, I hope. 0.9772. And this region here, okay, this corresponds to 0.6 minus 0.67. So we can't look up minus 0.67, but what we can do is we can find from here back, where this is plus 0.67. So in other words, we need this area here is the same as this area here. And to find this area here, we find the area from here back, which is the probability that z is less than 0.67. That's from here back, and if we take that away from 1, which is the total area, that'll give us this area, well, this area, which is the same as this area. Okay, so the probability that z is less than 0.67 is 0.7486, I think. 86. 1 take away the 0.7486 is 0.2514. And now we want this area take away this area, so we want this number take away this number. Okay, and that leaves you with 0.7258, or 72.58% of the data is within here. Okay, the next question. I'm going to rub that out. Right, now, reduced levels of LDH usually indicate that the medical treatments are working. Find the lower quartile of LDH levels for patients in this research group. Find the lower quartile. So what did we got? We had 0. Oh no, sorry, that was 210. Okay, and the standard deviation was 15. And they want us to find the lower quartile for the parents. Now, the lower quartile, a quartile means 25%. So the lower quartile would mean the number that's associated with 25% being that area there. Okay, so how do we get that number? Well, first we put it onto the normal distribution. So if we standardize that, that would be 0. We want the number here that corresponds to this being 25%. Okay. Now, again, we can't look that up. That would be the same as this number corresponding to be 25%. Okay. So what we actually want is we want that Z scored there. Okay. And if we figure out what that Z is, then this one is just the minus version of that. How do we find that? Well, that'll be the Z that will correspond to an area from here back of 75%. Does that make sense? So what you need to do, that's the number that corresponds to, when you look up that number in your tables, you will see 0.75. So what you need to do is you need to go to your tables and look inside the table for 0.75 and come back with the corresponding Z that corresponds to. Now, the Z that corresponds to is, let me see, I'm going to look it up in the log tables actually myself, because I don't see the way they have it here. And I don't have log tables. Okay. I think what that will correspond to is, oh, I don't have log tables. So you guys look it up and see what it corresponds to. That's the Z, so then that would be this minus number here. Okay? Now, we want to convert that number into a number that equates to the 210. So whatever Z you get here, you know that we call this W. W minus 210 divided by 15 is equal to the Z, or the minus Z in this case, okay? That you get when you look up the tables. And W minus 210, W minus 210 is equal to minus 15Z. And again, W will be equal to minus 15Z plus 210. So you should be able to work that out, okay? I'll have a look at it in the log tables. Unfortunately, my log tables are on my laptop, and I'm now using my laptop to record this.